parallax effect, a fascinating visual phenomenon. It was first described by the Greek philosopher Hipparchus in the 2nd century BC. This concept laid the foundation for understanding the relative distance between celestial objects and marked a significant development in the field of astronomy. In the realm of modern graphics and web design, the parallax effect has gained prominence for its capacity to create depth and interactivity. It's achieved by moving different layers of objects or images at distinct speeds when observed from varying perspectives, creating the illusion of three-dimensional space. Examples of this: think about a website when you're scrolling. One of the more prevalent uses of parallax on the internet is in website design. As users scroll down a page, elements in the foreground move at a different rate compared to elements in the background. This imparts a sense of depth and immersion. Parallax scrolling is widely employed in 2D video games to create the illusion of a dynamic and immersive environment. Background elements move slower than foreground elements, enhancing the gameplay experience. The parallax effect is also used in animation and filmmaking to simulate three-dimensional movement. By moving objects at various speeds, filmmakers can create captivating visual effects. In virtual reality applications, parallax is instrumental in rendering a realistic three-dimensional environment. As users move their head and bodies, the objects in the virtual reality space shift position accordingly, enhancing the feeling of presence. The parallax effect in astronomy, specifically stellar parallax, it works by taking advantage of the relative motion of the Earth as it orbits the Sun. Let's break this down real quick. It's fascinating how you can transcend from the heavens above into graphical elements on the computer, right? So see, astronomers select a nearby star as they target for measuring its distance. When they observe the star from Earth at a certain time, they record its apparent position in the night sky against a backdrop of more distant stars. This is the first observation. Astronomers wait for approximately 6 months, which corresponds to half of the Earth's orbital period around the Sun. At that time, half a year later, when the Earth is moved to the opposite side of its orbit, astronomers observe the same star again. They record its apparent position in the night sky once more. This is the second observation. Due to Earth's change in position in its orbit, the nearby star appears to have shifted its position slightly against the distant background of stars. This shift is called the parallax shift. By measuring the angle of this apparent shift, the parallax angle, and knowing the Earth's orbital radius, the distance from the Earth to the Sun, astronomers can then use basic trigonometry to calculate the distance to the star. The closer a star is to Earth, the larger the parallax angle will be. This means that the stars that are closer to Earth will exhibit more significant apparent shifts, making it easier to measure their distance accurately using parallax. Stellar parallax is a powerful method for determining the distances to nearby stars. It's fundamental for constructing accurate stellar distance measurements and understanding the structure of our galaxy, the Milky Way, as well as the broader universe as well. It does have limitations because the angles involved become very small for things that are very far away, and it makes it then difficult to measure their distances using this method. Other techniques like the use of standard candles and spectroscopy are employed for estimating the distance of stars and galaxies that are much farther away. These are Interesting Things with JC.